Okay, in this presentation we are going to look at continuous random variables. Here we have a continuous random variable x and it has the probability density function given by f of x equals 8 divided by x cubed if x is greater than 2 and 0 otherwise. So essentially the key range of values that we're interested in is x between 2 and infinity. Okay, anything outside that range of values, the integrals just evaluate to 0, so we can just disregard them. Check that f of x is indeed a probability density function, and then find the probability of x greater than 5 and then the expected value of x. So essentially this is the key thing here. The integral from minus infinity to infinity of f of x dx, that should equal to 1. And again, you can disregard anything outside the interval 2 to infinity. Okay, so what we can do here is evaluate the definite integral from 2 to infinity of 8 over x cubed dx. Okay, so working that out, we will get 8x to the power of minus 2 divided by minus 2. Okay, essentially 8x to the power of minus 3 to integrate that dx. So that's how we get that. That's a definite integral from 2 to infinity. Okay, so we just sort of simplify that. What we have there is minus 4 divided by x squared evaluated from 2 to infinity. So when we have 1 over x squared, essentially what we have here is 1 over x squared, where infinity is x. 1 over infinity squared is what we essentially have. Never mind the minus 4, you can disregard that. That is essentially equal to 0. So when we evaluate the upper limit, infinity, what we have is 0. When we evaluate the lower limit, when x is equal to 2, what we have there is minus 4 divided by 2 squared. So 0 minus minus 4 over 2 squared is 0 minus minus 1, and that is equal to 1. Okay, so it is indeed a proper probability density function, okay, because it does integrate to 1 over the range of values that we're particularly interested in. So the second thing is, what is the probability of x greater than 5? So what we do here is evaluate the definite integral from 5 to infinity. So essentially we can use our previous result. Okay, and we know that when x equals infinity, the definite integral evaluates to 0. So what we have left here is 0 minus minus 4 over 25. X squared being 25, so that works out to be 4 over 25, which is 0.16. Great. Finally, get the expected value of x. How do we do that? The expected value of x is the integral from minus infinity to infinity of x times f of x dx. Okay, and again we can just focus our attention to the range of values between 2 and infinity, because anything outside that integrates to 0. So essentially what we end up with is 8 divided by x squared, so rather than x cubed. Okay, so essentially what we have here is x times 8 over x cubed dx, which is 8 over x squared. So that is 8 times x to the power of minus 2. So when we evaluate that, we have 8 times x to the power of minus 1 divided by minus 1. That's a definite integral evaluated from 2 to infinity. So minus 8 divided by x evaluated from 2 to infinity. Again, 1 over infinity is assumed to be 0. And so that's why we get 0 there. And minus 8 divided by 2 is minus 4. So 0 minus minus 4, that gives us 4. So the expected value of x is equal to 4. Okay, that's it. We're done.